Welcome to Part 2, Question 4 of the 2003 Mathematical Methods Exam 1. In this video, we will be looking at the solutions and examination advice for this question. A reminder that this video is in no way endorsed by VCAR. Finally, as we progress through this question, you will notice that there is a colour-coded box next to each question to indicate how likely the CAS calculator is to be used efficiently in answering the question. So let's get started. For question 4, we have the graphs with the equations y equals negative x plus 1 and y equals 1 minus e to the power of negative x are shown below. And we know the graphs intersect at the point P, which has x coordinate of k. So this value here is k. For part A, we're asked to find the value of k correct to 3 decimal places. So to find k, we're going to simply let the two lines equal each other. So we're going to have 1 minus e to the power of negative x is equal to negative x plus 1. And now that's an equation that you will need to solve on your CAS calculator. It can't be solved by hand. On the CAS calculator, go into the main menu. Next, we want to bring up the soft keypad by pressing the keyboard button. And we want to solve an equation. And that equation is 1 subtract e to the power of negative x is equal to negative x plus 1. So now to solve that, we're going to highlight and go interactive equation inequality solve for x, and hitting OK will give us one solution, 0.5671, and we now need to round that correctly for our question. So from the calculator, we found that x was equal to 0.567 correct to 3 decimal places. So therefore, our value of k will be equal to 0.567 correct to 3 decimal places. So that's the answer we needed for part A of this question. For part B, we want to write down a definite integral, the value of which is the area of the shaded region. So this is a question that is the area between two curves. So we know that the area between two curves, between the terminals, in this case between 0 and k, and because k is well defined, we can use k as a limit for this question. It is going to be equal to the upper curve, which in this case, inspecting our diagram, is the green line, which has the rule y equals negative x plus 1. So by upper, we just mean that it is above the curve for the region that we're considering. So we're going to have negative x plus 1, the upper curve, subtract away the rule for the lower curve. And for this question, the lower curve is this purple graph, that's the exponential rule, with a rule y equals 1 subtract e to the power of negative x. So we're going to subtract away in brackets, and that's really important, that we have 1 minus e to the power of negative x, and of course we're going to integrate that with respect to x. So that there is a definite integral, the value of which is the area of the shaded region. And finally for part C, it says hence find the area of the shaded region, and for this question it's going to be correct to 2 decimal places. So to evaluate that integral, we need to go to Math 2 and type in the integral between 0 and the value of k, and now we're going to use more decimal places than the required 3 that we rounded to in part A, so we'll drag our entire answer down. And then in here we need to do an upper subtract lower calculation. So I'm going to set up the brackets straight away so that we don't make any mistakes. So the upper curve was the negative x plus 1, so I drag that into the first position, and then we subtract away the rule for the lower curve, which was 1 subtract e to the power of negative x, and then we're going to integrate that with respect to x, and hitting execute we can change that to a decimal, and that is our answer of 0.272, and we'll now need to round it correctly. So from the CAS calculator, correct to 2 decimal places, that is 0.27, and as it's an area we can write it as 0.27 units squared. So that is the answer to part C of this question. So from the examiner's report, we can see that 87% of students got part A correct, which was finding the value of k, and that the examiner goes on to say that it was generally well done, although a few students made rounding errors, which caused them to lose that mark. For part B, 3/4 of students got that answer correct, and again it was generally well done, And in particular, the comment that some students were careless and omitted the brackets surrounding the 1 subtract e to the power of negative x, or simplified incorrectly, are important things to note. So you need to make sure that where brackets are required, you include them, and that if you are going to simplify, make sure you simplify it correctly. And finally, for part C, we can see again about 3/4 of students got this question correct, and that it was generally well done in the exam.